You ever look up at the stars and just feel, well, completely tiny? That feeling.
Oh, yeah. Humbling, isn't it?
Right. Now imagine taking that feeling and just multiplying it, like ridiculously. That's kind of where we're going today because we're asking, how big can a star actually get?
And the answer, or at least one of the biggest contenders we know, is UY Scuti.
Exactly. So our mission here is to really dig into this red supergent UY Scuti. We want to understand its, frankly, mind-boggling scale and what's going to happen to it eventually.
And it's got history, too. German astronomers first put it in the catalogs way back in 1860.
Right. It was initially BD 12 degrees Fevi 55.
And later it got the name UY Scuti, marking it as the 38th variable star found in the constellation Scutum.
Okay, let's talk scale, because this is where it gets
Hey.
almost impossible to really visualize. The current estimate, I believe, is a radius of about 909 solar radii.
That's the recent figure, yes. 909 RA, we call it. So 909 times the radius of our own sun.
Which translates to a volume. What was it? Something enormous.
It's about 750 million times the sun's volume.
750 million. Wow.
Yeah. Here's the analogy that helps. If you swapped our sun for UY Scuti,
Okay.
its surface, the photosphere, would stretch out way past Mars's orbit.
Past Mars.
Seriously.
Maybe even reaching into the main asteroid belt, depending on the exact measurement you use.
So, Earth and Mars would just be inside the star.
Gone. Vaporized.
Yeah. Yeah, that's a terrifying thought. And it's not just sitting there, right? It's described as dust enshrouded, and it pulsates.
Exactly. It's a semi-regular variable star. It brightens and dims over a period of roughly 740 days.
So its apparent magnitude shifts between about 8.29 and 10.56.
Correct. But even at its brightest, despite being incredibly luminous intrinsically,
Yeah.
you can't see it with the naked eye.
Why is that? Is it just the distance?
It's two things, mainly. The distance is huge, about 5,900 light years, and its location.
Ah, the zone of avoidance.
Precisely. It's in a part of our galaxy within the Cygnus Rift that's just thick with interstellar dust. It obscures our view, like looking through cosmic fog. And that huge distance, 5,900 light years, that creates problems for measuring it accurately, doesn't it? I saw conflicting figures in the sources.
It absolutely does. There was an older estimate from 2012 using the Very Large Telescope that put it much larger, around 1,708 solar radii.
Right, versus the newer 909 RA. That's a massive difference.
It is, and the core issue is measuring that distance accurately. We use parallax, but for UY Scuti, the parallax data we have has a lot of, well, astrometric noise. It's shaky.
So uncertainty in distance translates directly into uncertainty in size and luminosity.
Exactly. A small error in distance calculation gets magnified hugely when you're calculating the actual physical size of something so far away. It's fascinating that even for such a giant, there's still debate.
So we're basically saying for one of the largest stars we know of, we're still kind of guessing its true dimensions. That's wild.
It highlights the challenges of astronomy at these scales.
Okay, before we jump into what happens next for UY Scuti, its dramatic destiny, let's quickly thank our partner.
Absolutely. This deep dive is supported by Silk. If you need help with AI training, automation, integration, software development, or figuring out how AI agents could benefit your business or even your personal life, you should check out embersilk.com.
Thanks again, Silk. All right, so the fate of UY Scuti. It's burning helium now. What comes after that for a star this massive?
Well, it's on a path towards core collapse. Given its mass, it will eventually start fusing heavier elements until it gets to iron in its core.
And iron is the end of the line for fusion, right?
It is. Fusion stops releasing energy, the core collapses under gravity, and boom, a supernova.
What kind are we expecting?
It's predicted to be a type I, maybe an ion, or possibly a type I big supernova. But before that final explosion, it's likely to get interesting.
How so?
It's expected to actually evolve back towards hotter temperatures for a while. It might temporarily become a yellow hypergiant, or maybe a luminous blue variable, or even a Wolf-Rayet star.
And shedding its outer layers violently during that phase.
Very likely, yes. Ejecting huge amounts of material before the final kaboom. So when we look at UY Scuti, we're really seeing a star in its final spectacular act.
And speaking of shedding material, you mentioned something about its current mass loss.
Ah, yes, that's incredible, too. It's losing mass at a rate of about 5.8 times 10 to the minus 5 solar masses every year.
That sounds like a tiny number, but for a star, that's a lot, isn't it?
It's a huge amount of mass being blown off into space. This creates what we call an extensive circumstellar environment.
Like a shroud around it.
Exactly. An enormous, complex, sort of invisible envelope of gas and dust that it's creating itself. It's cloaked in the material it's shedding as it prepares for its end. Makes you wonder what else is hidden inside that shroud.
A truly massive star preparing for oblivion, wrapped in its own remnants. What a thought.
Indeed.
Well, if you enjoyed this deep dive into cosmic giants, please do subscribe to the show.
And hey, maybe leave us a 5-star review if you can. It genuinely helps other curious minds find us.
It really does. Thanks so much for tuning in.